Good morning. Hello, everybody. My name is Mr. Boder, and this is 9th grade science. Here's what we're doing today. As you can see, the learning objective today is to describe the energy transformations in a rubber band launcher. A what? A rubber band launcher, everybody. This is a rubber band launcher. We're going to be using these today in class. So you're going to describe these energy transformations. We're going to go from stored, remember, elastic potential energy into kinetic energy. And then kinetic energy, if it's rising up in the air, is going to turn into some gravitational potential, will turn back into kinetic, etc., etc. Here's how we're going to be doing that. You're watching this video now. You're going to then grab a rubber band launcher lab. You probably don't have that yet. If you don't, let's go ahead and pause the video and go grab the rubber band launcher lab sheet. Okay, I've assumed that you have paused the video and you've already got the rubber band launcher, and now we're back. Let's take a look at the introduction of the rubber band launcher lab. So on the front, the goal of your ping pong launcher, your what? Your ping pong launcher. Oh, I haven't really talked about the ping pong launchers yet, have I? They are the next big thing we're going to build. Do you remember the cranes that we just built recently? Yeah, it's going to be sort of like that. You're going to get a weird set of supplies, and then with that set of supplies, you're going to have a goal. Your goal this time is going to be to shoot a ping pong ball into a target. The only thing you will know going into the competition day is that the target could be 2, 3, or 4 meters away, but you don't know what distance it is until you get there. I will then tell you the distance, and you're going to have to adjust your launcher. So you'll have all this data collected because you'll have like all these testing records of your launcher, just like that crane, those testing records and the engineering lab notes. Yeah, you're going to take those as you build your ping pong ball launcher, and you're going to then be like, oh, okay, the 3 meter mark, got it, Mr. Boder, boop, boop, boop. And then your launcher, your ping pong ball, just poop, bullseye, 3 meters like that. Okay, so the goal of your ping pong ball launcher will be to determine what angle you should use to shoot your ping pong ball a certain distance into the target. The source of the energy will be elastic potential energy from a rubber band or a spring or some other source of energy. And you know, if you've ever been shot by a rubber band, then you know it has energy in it, enough energy to smack you in the arm and cause a sting. Okay, the purpose of this lab today will be to investigate how trajectory, that's like launch angle, okay, yeah, affects the distance a rubber band will travel. Before we begin, let's make some predictions, kind of get our brains into it. What angle do you think will give the greatest distance? Is that going to be like a perfect 45? Or is it going to be more down like a 30-degree angle, or like low like a 15 or 10 degree? What do you think is going to be? Oh, maybe a high angle, like an 80% lob is going to be like the most distance. What do you think? Make a prediction. Okay, you got one? Good. Number 2, what angle will cause the greatest height? Is that going to be like a vertical 90-degree angle, or is it going to be like a 80 degrees higher? What do you think is going to be the highest height? Finally, math review. What is a complementary angle anyways? I forget. Complementary angles. I don't know. Talk to the geometry kids in your group, huh? Okay, part 1, changing the launch angle. The first thing we're going to do is we're going to be changing the launch angle and measuring how that affects the launch distance. Procedure. You need to loosen this wing nut perhaps to kind of like adjust your angle. Just a pro tip, the wing nut is attached to a screw on the back, so anytime you're spinning the wing nut, you should probably be holding on to the screw so that you're not just spinning and spinning and spinning. Yeah, okay. Let's take a note about how this measures. Okay, let's say I want to put it right on the 50-degree line. So you'll see at my protractor. My protractor here has a 50-degree mark. Should I line up the top of this ruler with 50 degrees, or should I put the 50-degree mark right in the bullseye center of my viewfinder? That's right in the center of the viewfinder. That's what you need to be measuring your angle with. Don't measure it with the top of the line here, because you'll notice your pivot point is in the center of the ruler here, so you need to be in the center of your viewfinder when you adjust your angle. Okay, just a little note about that. For each trial, you're going to have your launcher set up on a launch test area. I have a launch test area set up right here. As you can see, it's in the lab. I've got some tape marked out, certain distances. Each tape is a 1 meter away. And then I'm going to set my rubber band launcher right there on the launcher zone. And I'm going to pull my rubber band back. The way I'm going to do that is I'm going to hold on to my launch. I'm going to feed it into the little knots there, and then I'll pull it right back. We're going to start with, how far does it say to pull it back? a stretch distance of 15 centimeters. And then I'm going to have it down on my line, and I'm going to launch, and there it goes. Okay, so I've launched one. You're then going to measure the distance. I recommend using meter sticks, and you'll notice I've got the tape marked out for easy access. My rubber band looks like it's halfway between the 3 and 4 meter mark. It's way out there. So what I'd do is I'd slide my meter stick over, and I'd be like, okay, it's 3 meters and 25 centimeters. Or I don't know, get exact, get your meter stick over there. And you're going to then record that underneath trial 1. Here's the problem, though. I need you to record it in centimeters. What are you recording in? Centimeters, not meters in centimeters. You're recording in centimeters. So if I'm 2 meters and 25 centimeters, how many centimeters is that? 2 meters, 25 centimeters. Oh yeah, 2 meters is actually 200 centimeters, right? Because a meter is 100 centimeters. So that would actually be 225 centimeters. Okay, make sure you're recording everything in centimeters. Don't measure with the inches side. Okay. Then you'll add up your trials. You'll average them. You're going to go through all the different angles here. It's going to be great. Then we're going to switch to part 2, changing the stretch. Part 1, we kept everything constant with the stretch. We always stretched it to 15 centimeters to try to get the same power, and we were only measuring the change of the angle. Now we're going to change the stretch. I'm going to have you actually set the angle to 30 degrees. It might say 45 right here, but let's change that. Oh, I got a couple changes to make here. Change those to 30 degrees. Also, you're going to need to change instruction number 2 here. For this trial, you will adjust the stretch distance. You're changing the stretch distance, not the stretch angle. Also, that's step number 4. Sorry. You're going to measure the distance in centimeters again, using the meter sticks, and then complete your data table. Trial 1, 2, 3. Just a pro tip as you go through here. Set the angle. Do trial 1, trial 2, trial 3, okay? Don't adjust the angle in between each trial. Part 3, you're going to change the band thickness. You have actually 2 rubber bands at your station. You have a thin rubber band and a thick rubber band. We'll set it to 45 degrees. Run it through 3 times with the thin rubber band. 1, 2, 3 trials. Average it out. And then 45 degrees, 15 centimeters, same stretch. But run it through with the thicker rubber band. See which one went further. Okay, you got some post-lab questions. You're going to use the averages to make a scatter plot graph of the distance versus angle. Okay, if it's distance versus angle, which of these data tables are we looking at? Is part 3 an angle? No. Does part 2 change the angle? No. Part 1 is all about changing the angle. Look at that, changing the angle. Okay, so we're going to use the data table from part 1 here to make a scatter plot of the distance versus angle. So which one was your independent variable? Which one was your dependent variable? Well, let's see. Independent variable is one I changed. I was purposefully changing the angle, and that goes on the x-axis. Okay, so angle goes on the x-axis. And then the one that was depending on what I did was the dependent variable, and that you have to figure the rest out. Answer some questions. Then you're going to make a bar graph of stretch versus distance. You'll notice stretch needs to be on the bottom here. There's probably only 2 marks, so it'll be a bar graph. And then you'll have distance on the y-axis. Make a bar graph of the thickness versus the distance. Should we calculate averages or all trials? Talk to your group. Okay, you got some more post-lab questions. There's an extension on the back. Extension people, check this out. If you're wanting a challenge, if the rest was easy for you, get onto this back. It's got some really interesting questions about like the difference between our theoretical models of how things should fall in trajectories versus what happens when air resistance is involved. Okay, so get onto that extension. I'm coming back to our presentation here after you've watched my video and after you've done the lab and after you've answered the post-lab questions. I have a rubber band launcher check-in. This is for a formative grade. It's got a formative grade. You need to scan this or go to this URL. They're the same thing. It's a Google form. Answer it. I'm going to be grading it at the end of the day and emailing you your grade to let you know how you're doing. By the way, there's a test next class, right? Yeah, the test is next class. You got that review packet. The answer key is going online very soon. If you finish early with all of this stuff and you have some extra time, grab a kinetic energy problem set packet. Well, it's just 1 page, actually. It looks like this. It's got these little pictures on it. Their worksheet is on the front table. There's an answer key going up on Moodle. Check the answers after you finish. It's practice for the test. It's not going to be graded, but it's good, solid question practice for the test.